And we're rolling. Okay. Right. Okay. So anyway, so B2. B2 is inorganic nomenclature. It's how we're going to name compounds. And the most important thing about inorganic nomenclature is, one, it's easy when you get the pattern, but you got to get the pattern. And one of the most important things about getting the pattern is realizing what's a metal and what's a non-metal. So if you wouldn't mind, go ahead and point to the big periodic table. Point to where the metals are on the big periodic table. Yeah, so almost everything, wow, it's really out of focus now. Almost everything up here are metals. These are the metals, ignoring hydrogen. From lithium over down here, this little triangle right here, these are all metals. And metals have a positive charge. They're placed in the front. Because we read from left to right, we're going to put the front positive thing first, and then the negative thing after. And then, of course, we have our non-metals: carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, iodine, astatine, and the noble gases. And then you got your metalloids: boron, silicon, arsenic, tellurium, sometimes germanium as well. So the naming system is very, very easy if you remember this is a metal, it goes first. This is a non-metal, it goes second. For instance, what is this? Oh, so the whole thing. Sodium chloride. Okay, yeah, you've encountered this a number of times. This is table salt. This is sodium chloride. What is this? Lithium bromide. What is this?
Magnesium chloride.
Magnesium chloride. And what is this?
Magnesium oxide.
Magnesium oxide. So just from that one little crossword you did, and just from being in the class and hearing me talk about compounds, you picked a lot of it up. Just like if you go down to Mexico for a few weeks, you'll pick a lot of stuff up. Well, just being in chemistry, you pick up the compounds. And the system is very simple. It is the metal, the non-metal-ide. The metal, the non-metal-ide. So the metal does not have its name changed. The non-metal, it drops the last syllable or the last two syllables in the case of oxygen, and it's replaced with ide. So chlorine becomes chloride. Bromine becomes bromide. Oxygen becomes oxide. Does that make sense? Okay. So these are called binary compounds. Binary means two things. Like binary computers, they either have a 1 or a 0. If it's a binary decision, it's a yes or a no. It's an east or a west. Well, a binary compound is composed of only, I don't know what that is, only two things. A positive and a negative. And in this class, almost everything we do is going to be binary. Okay. Almost everything we're going to do is binary, which is why if you saw this written down, NaCl, you know this is not sodium, carbon, and iodine, because that would be three things. Sodium, carbon, and iodine would be three things. You know it's sodium chloride. Does that make sense? Yes. All right. Any questions before we move on? Okay, like it is on the screen, nomenclature simply means naming system, and inorganic deals with compounds that don't necessarily come from crude oil. Yeah. What? Organic does not mean from plants. Organic does not mean without chemicals. Organic means carbon and hydrogen, usually from crude oil. Like, you're sitting on a table, or you're sitting on a chair. You know your chair is organic?
It's made from crude oil.
It's made from crude oil. The plastic came from crude oil. That gum you're eating, the gum you're chewing, made from crude oil. It's organic.
Oh.
I mean,
America.
Did you know that the gum you're chewing uses artificial rubber that was once crude oil, sitting in the bottom below Alaska or Texas or Colorado or Venezuela or Saudi Arabia?
It's probably one of the last.
It doesn't taste like crude oil, but yeah. But yeah, gum is made from artificial rubber that came from crude oil. So organic basically means carbon and hydrogen from crude oil. Inorganic is stuff you can mine. That's what basically we're going to like mining things. Dig it out of the ground. All right. So, take a look at these and go through this and decide which of these things are anions and should have their name changed, and which of these things are cations and should not have their name changed. So take a look, go through it, and then we'll talk. I'll see if you can actually use your voice, and you can use your voice as a tool for benefits. So go through each of these, and it's like, it's a metal, not going to change its name. It's a non-metal, we should change its name. Okay. Magnesium, should we change the name?
No.
No, it should stay magnesium. Iron, should we change the name?
Yes.
No, it's a metal. We should keep it iron. Fluorine, should we change its name?
Yes.
What should we change it to?
Chloride.
Chloride. Sulfur, should we change its name?
No.
Yes, sulfur is a non-metal. We should change it to sulfide. Sodium, should we change it? No. Chlorine, should we change it?
Yes.
What should we change it to?
Chloride.
Chloride. Back row, are you with us? Okay. This is manganese. Should we change it?
No.
No. Calcium, should we change it?
Yes.
No. I realize when you think calcium, you think of bones and like white concrete. No, it's still a metal. Yeah, you just don't normally see calcium by itself. So it's a metal. Don't change it. Aluminum, should we change it?
No.
No. Nitrogen, should we change it?
Yes.
Yeah. What do you think we should change it to?
Nitride.
Nitride. Yeah. So ogen, just like oxygen, ogen basically just becomes I. So nitrogen becomes nitride. Okay. Oxygen, should we change it?
Yes.
What should we change it to?
Oxide.
Oxide. Chromium, should we change it?
No.
No. Bromine, should we change it?
Yes.
What's we going to change it to?
Bromide.
Bromide. Zinc, should we change it?
No.
Carbon, should we change it?
Yes.
Carbon's an interesting one. Because remember we learned about, you're all right, whether you said yes or no. The thing about carbon is remember how carbon can be a positive 4 or a negative 4?
Yeah.
If carbon finds itself in the positive 4 position, it's going to be carbon something-ide. If it finds itself in the negative position, it's something carbide. Make sense?
Yeah.
Yes. If carbon finds itself in the positive position, it's going to be carbon something-ide. If it finds itself in the negative position, it's going to be something carbide. Okay? So, cobalt, should we change it?
No.
Nope. Silver, should we change it?
No.
Nope. Boron, should we change it?
Yes.
Probably. Sometimes boron acts as a positive 3 and sometimes acts as a negative. Boron, because it's a metalloid like carbon, is different. Lead, should we change it? No. Potassium, should we change it? Okay. It seems like you guys got the general gist of it. Any questions? Give me a thumbs up if you got the pattern and you're ready to move on.
Oh, wait, why? Wait,
Okay.
why do we change lead?
Why don't we change lead?
Yeah.
It's a metal. I know I know it finds itself into the P block, but the triangle kind of goes this way.
Oh, okay.
So it's this, and the triangle goes whoop.
Okay,
Yeah. All right. So don't need to write anything down here because you've already got the pattern. Magnesium and chlorine becomes magnesium chloride. Simple. Okay. Are we ready to move on? All right. So some of you might need to write these down. Some of you might already have the pattern in your head. It's up to you. What does oxygen become?
Oxide.
Oxide. What does hydrogen become?
Hydride.
Hydride. Again, the ogen just becomes ide. So oxygen and hydrogen. Oxygen becomes oxide. Hydrogen becomes hydride. What do you think sulfur is?
Sulfide.
Sulfide. Chlorine?
Chloride.
Chloride. Fluorine?
Fluoride.
Fluoride. Iodine?
Iodide.
Yeah, iodide. So that's one of the ones where it actually sounds like it should be iodide, but we should make it iodide. So that's one you might want to write down, iodide, because the IO is still before the consonant, so iodide. Nitrogen?
Nitride.
Nitride. Carbon?
Carbide.
Carbide. bromine, and a really fun one, phosphorus. Phosphide. Yeah, phosphide. So if anybody wants to scribble those down, I'll give you a minute to scribble those down. If you want to scribble them or take a picture, it's up to you. But again, that's it. Now, in this class, we're not going to have any exceptions. So the metals are going to be minus, or they're going to be positive, the non-metals are going to be negative. Understand that should you find yourself in a more advanced chemistry course, like chemistry AP or a college chemistry course, carbon, well, I talk about carbon, go that way, but nitrogen can actually find itself a positive 5, and sulfur can actually find itself a positive 6. But not in this class. So I'm going to try to steer you away from, protect you from as many exceptions as I can, but just realize that does exist.
Okay.
Moving on?
Yeah.
If you have questions, wave your hand around. If you're good, give me a thumbs up. Third row, we're good? Third row? No? Third rows are like,
I'm thinking about boys.
okay, now, that's the non-metal, that is the metal, non-metal system. That's the, I'm not going to judge. Or girls. So that's the system we use when we have a metal and a non-metal. Metal, non-metal I. Okay? That's the easy one. Now, so we've mastered level 1. Level 2. What is this compound?
Carbon dioxide.
It's carbon dioxide. You've learned this. So everybody knows CO2 is carbon dioxide because that's what you're breathing out that's killing the planet. Stop killing the planet. Actually, you're not killing the planet. The planet's going to be just fine. You're just killing your ability to live in it. So, yeah.
Oh, so if we stop breathing, everything will stop.
Yeah, the carbon dioxide, that's not going to harm the planet that much. It will harm your ability to grow food. So you won't hurt the planet, you'll just hurt your ability to live in it. Yeah, so, yeah. Okay, anyway, so this is carbon dioxide. Think about it, man. People are like, you're going to kill the planet. Next time somebody says you're killing the planet with all your diesel exhaust and your cars and your meat, just remind them, the planet's really big. You're not going to kill the planet. You're just going to kill your ability to live on it. So,
Yeah, that would be a funny one.
yeah. All right, so CO2 is carbon dioxide. So we've added something new. We've added a prefix. That means two.
Before. Oh.
Okay? So that's carbon dioxide. What is this?
Carbon oxide.
This is carbon monoxide. This is the one that will displace oxygen out of your blood if you breathe it too much. Yes?
You're the reason why.
No, it's natural gas. So the natural gas will displace the oxygen, but not in your blood. It'll displace the oxygen in the room, but your lungs will not mistake methane for oxygen. Your lungs will mistake carbon monoxide for oxygen. So if you breathe a lot of carbon monoxide, your lungs are like, looks about the same, come on in. And it makes your blood hot pink, your face will turn pink, and you'll eventually pass out and die.
Wait, but where do you breathe? Like, where do you breathe in carbon monoxide? Like,
If you have a poorly running car, you make a lot of carbon monoxide.
Is that why you can't like shut the garage door? Why you die?
It's mostly because of the carbon dioxide and the fumes. But if you have an internal combustion system, like a water heater or a car, and it's not working properly, it'll make a lot of carbon monoxide.
oh.
All right.
You have to, but do you have to be
So,
in like a
guys,
lot
you need to come back to order. Okay? If it sounds like I answered questions and you guys just talk about other crap, then I can't answer questions. So if the questions are relevant, I want to answer them because this is part of learning. But if that means I'm talking to Kenny and 30 people are talking to each other, that's a problem. Okay? So when I'm talking to one student and answering a question, be like, well, this isn't going to be on the test. Hey, what are you doing? Let's talk about football. No, don't do that. Okay. Kenny, question.
you have to breathe in like a lot of carbon monoxide to pass out? Like how?
Yeah, you do. You really do.
Okay.
So if you're breathing carbon monoxide, your brain is going to tell you something's wrong by making you nauseous and dizzy. That's like one of the things your brain says, this is not right, I'm going to make you nauseous and dizzy to get your attention. So if that happens, like if you're in a wood shop and you have electrical and mechanical things going on, and there's burning going on, and you start feeling dizzy, you get fresh air. Okay, so yeah, so it's really hard to die from carbon monoxide poisoning if you're conscious.
Okay.
You can't smell it. Yeah, carbon monoxide, oxygen, carbon dioxide, and methane, and all those small gases, they're too small for you to smell. Just like you cannot taste water, water molecules are too small for you to taste. These gas molecules are too small for you to smell. So what we do is we dissolve giant molecules into the gas that you can smell. Just like you can taste sugar, because sugar is a really big molecule when it's dissolved in water, you can't taste water. Okay, so carbon dioxide, carbon monoxide, and then we learned what 4 is. Remember what 4 is? Tetra. Remember 4 orbitals is a tetrahedron, or 4 domains is a tetrahedron? So that just leaves us with 3. What do you think 3 is? Tri. Yeah. So the system goes like this. If you have 2 non-metals, only non-metals, then you use the Latin prefix mon, or di, or tri, or tetra. Only for non-metals. Now, if you look at a vitamin container, it's going to give you things like disodium and tricalcium, because it uses an old system of naming which we don't use anymore. And I don't want you to sound like an idiot when you go to college. I want you to know the actual naming system, not the naming system that was here 100 years ago. Okay, now, all these things have one nonmetal in the front. Is this nonmetal positive?
No, it's
No.
negative.
These are not positive, negative things. These are not ionically bonded, and if they're not ionically bonded, they must be what kind of bonded? Covalently bonded. These are not ionically bonded. It's not a positive, negative thing anymore. These are covalently bonded. They are covalent molecules. Okay? So ionic, when you have a metal and a nonmetal, you make an ionic bond. If you have 2 nonmetals, you make a covalent bond. These are covalently bonded. So there's no positives or negatives involved. Okay. Give me a thumbs up if that concept makes sense. Okay, because a lot of you aren't gonna I know it now, but I'm not gonna know it tomorrow. So this is one of those things you want to internalize so you know it tomorrow. Now, mono in front of something is optional. Okay? So if you called this monocarbon monoxide, that wouldn't be wrong. It would just be a couple extra syllables. If you called this monoboron trifluoride, that wouldn't be wrong. It would just be 2 extra syllables. So if you have something in the front, that is optional. The mon is optional when there's 1. So far, so good? Okay. If you gotta understand the pattern, give me a thumbs up. All right. And if you understand the pattern, then what is this?
Nitro oxide. Nitro tetraoxide.
Getting there. Try again.
Nitrogen
Nitrate.
Dinitrogen tetraoxide. This is dinitrogen tetraoxide. Dinitrogen tetraoxide. This is the yellow crap that forms over this strip when you drive into the valley in the morning, like on a Saturday morning, and you drive over the hill into the valley, and you see that yellow band of crap over the top of the strip. That's that. It comes from exhaust pipes in California. So dinitrogen tetraoxide. I'm sorry, what?
Let's go Cali.
Yeah.
When we get from Austin.
A good portion of our air pollution comes from them. Thanks, Los Angeles. Bad enough you gave us tourists. We love LA tourists. Drop off your money and go home. So, okay, does that make sense? If you want to know what the other prefixes are, here they are. But you're very rarely going to see them. And they basically work just like geometry. So, penta, hexa, hepta, octa, nona, deca, just like geometry. Yeah, sometimes septa means 9, but in chemistry we're going to use hecta or hepta. So, penta, hexa, hepta, octa, nona, deca. Octa, nona, deca.
That hurt my brain.
Octa, nona, deca. Penta stuff, hexa stuff, hepta stuff, octa stuff, nona stuff, deca stuff. Okay. If you have questions, wave your hand around. Okay. If you'd like to do some practice, give me a thumbs up. Here comes the practice. So, go ahead and write each of these formulas down with their name. And work in parallel with your neighbor. Don't lean over and say, "What did you get?" until you've actually done it yourself.
So what did you get for all? So what did you get? That's
Can I turn the light on so you can see your nose better? No? Okay. Your eyes have adjusted.
Can you like seriously?